Howdy, everyone. Welcome to three-dimensional geometry day, I don't even know, 2, 3. Um, today we are going to be going through the next phase of this unit, which is we're past the basics and the vocab. We're moving on to surface area. Surface area is going to be broken down into a few different days. So if you don't feel super strong with it today, don't freak out. We're going to be doing this a couple days. However, try your best to grasp it. Most importantly is, I think, just understanding what the heck surface area is. We're doing a three-dimensional unit, so it sometimes can feel like you don't really know what we're talking about because you think, oh, it's what the space an object takes up, and that's not exactly what surface area is. So let's start there. What is surface area? So to answer that question, this might sound a little bit weird, but if you can, pause the video and go grab like a cereal box or some sort of like cardboard food box that something might come in from the grocery store. And if not, if you don't want to do that or don't have one, you can just envision it. But if you did grab a box and are unpausing the video right now, this is what surface area is. If you could take that cereal box, and right now I'm holding a Captain Crunch box in my hand because I like the Captain. Captain Crunch is great. If you could take that cereal box and carefully, without ripping it, unfold at the seams, like at the top of the box, you've probably already opened it to get to the stuff that's inside. And then if you could also open up the bottom of the box, like carefully peel it so it doesn't rip, then you lay that box flat. So you've unfolded it and you laid it out flat. That's what surface area is. Think about what the words are in this thing. Surface area. We're going to be finding the area of the surfaces of a box. So that would be like all of the space where there is writing on the box, like where Captain Crunch is and where the nutrition facts are on the side and where the like cool pictures are that you look at when you're eating. That's exactly what we're talking about. I found a picture online of a box of cereal in the like direction that I'm trying to talk about. So I'm going to put that on the screen real quick so that you can see it. All right, so this is a box of Cheerios, and you can see exactly what I'm talking about, right? The person unfolded the box and laid it out flat, and look, here's the surfaces of the box. This is the front surface, this is the back surface, this is the side, this is the other side of the box, and then you even have these surfaces up here. This would be the top flaps of the box. These would be the bottom flaps of the box. So when you're finding surface area of a three-dimensional shape, it's actually something two-dimensional that we're finding. We're laying that three-dimensional shape out flat, and we're going to find what's the area of this space and the area of this space and the area of this space and this space, and we're going to put it all together. So surface area, if we're defining it, it is the area of all of the faces added together. So the way that we're going to do this is we're going to be using something called a net. And I don't mean like a butterfly net or like a fishing net. A net in geometry, I'll write this out, a net. A net in geometry refers to the flat two-dimensional representation of a solid. So here in my on the screen, I've got a three-dimensional rectangular prism, and a net is a fancy way of saying if I could take that box and unfold it, like start to lay it flat like I did the cereal box, and then ultimately lay it flat, this final product here, this is a net of the original 3D shape. It is the flat two-dimensional representation of that shape. And we're going to use nets today to find surface area. Because once you've got the thing laid out flat, It's just a matter of finding the area of this and the area of this and this and this and this and this, and then adding it all together. And it's easy for me to say that. It makes much more sense once you put it into practice. So let's do this. Let's find the surface area of this rectangular prism. Now, I'll be quite honest with you all. I was horrible, and still kind of am, at visualizing nets. Like, it's hard for me to take something that's drawn out on paper like this rectangular prism and then figure out how to peel it apart and lay it flat. Some of you, and some people are really good at this. Naturally, they can just kind of see it. They don't have a problem drawing a net. If that's you, the net would look something like this, and it's color-coded. I said I'm bad at this, so there's got to be an alternative for people like me, and there is. This is the way I do it. I don't draw a net because this gives me trouble. Instead, and today, just by the way, we're only looking at rectangular prisms. So we will look at other shapes going forward, but today is straight up rectangular prisms or cubes. So here's what I would do. I know that a rectangular prism is made up of 1, 2, 3, 4, 5, 6 rectangles. 2, which we're going to call the top and the bottom. So I start by labeling things by name. Top and bottom. So this is 2 sides. And then there's a back and a front. The front is the side you can see, and the back is across from it. So 2 more sides. I call them back and front. And then the other 2 sides I'm going to call the sides, because there's a blue side here and a blue side here. So I'm going to call these side, side. So altogether, I've counted 1, 2, 3, 4, 5, 6. And I just draw one of them. So the top and the bottom. In this shape, they are the red image, the red top here. So the top and the bottom are a 7-inch across by 4 inches deep. So 4 by 7. Now, how do you find the area of a rectangle that's 7 inches by 4 inches, length times width, which is 28? But, big but here, you have to double this times 2. Why? Because it's a top and a bottom. There are 2 rectangles that are 7 by 4. So 7 times 4 is 28, but you have to double that because there's 2 of them. So the area of the surfaces that are the top and the bottom is 56 inches squared. Our next shape is the back and the front, and that's a rectangle. And I'm going to highlight that in black pen. So there we go, back and front. And it's clearly 7 inches by 3 inches. So 7 by 3. And there's 2 of those. So I'm going to do length times width. That's the area of the back and the front. Or excuse me, one of them. But I have to double it because there's 2 of them. So the area of the back and the front in total is 42. And then the last side that we're going to look at is what we're calling side and other side. So here we go. That's this side right here. And it's identical other side over here. And those are 4 inches across by 3 inches high. So when I draw that, I'm going to do 4 inches across by 3 inches high. And then the area of one of those is 4 times 3, which is 12. But I've got to double that because there's 2 of them. So in total, it's 24. So now, what is the surface area, aka the area of the surfaces? To find that, we're just simply going to add up 56 plus 42 plus 24 to get our grand total of 122 inches squared. That's our label because we're talking about area. Woof! A lot of work there. If you are a person who can draw a net, good for you. Do it. If you're not, maybe try it my way. I organize things by portions. Top and bottom, they match. Back and front, they match, side and side, they match, and I just doubled everything. And I'm going to do one more example because I think we'd all benefit. I'd benefit from doing another one. Here we've got a nice orange rectangular prism, and we're going to find the what? Surface area, the area of the surfaces. All right, if you can draw your net, good for you. It should look something like this. I can't do that very well, so I'm going to take a different approach. I am going to label this as the top and the bottom. I'm going to start there. All right, top and bottom. So the top and the bottom are identical rectangles that are 7 inches by 3 inches. So I'm going to draw one of those, 7 by 3, and the area of that is 21, but I have to double it because there's two, a top and a bottom. So in total, 21 doubled is 42. Cool. Now we have to deal with what I'm going to call the back and the front. So back and front. All right. So the back and the front are a rectangle that is 7 inches by 5.4 inches. So to find the area of that, 7 times 5.4, which is 16, wait a second, that's not right, 37.8. But I need to double that because it's a back and a front. So in total, I'm going to just double check with a calculator so I don't make a silly mistake. Feel free to use one yourself. That's going to be 70. My computer's freezing. 75.6. All right, getting down to the wire here. And then the last pair of sides in this rectangular prism are what I'm going to call side, side. I'll use blue for those. Side, side. And both of those are an identical rectangle. And that rectangle is 3 inches on centimeters on the bottom, and 5 4/10 centimeters going up and down. So 5.4 by 3. So to find the area of that, it's simply 5.4 times 3, which is 16.2, but I need to double it to cover both of the sides, and that's going to be 32 4/10 total. It's a sloppy 4. And then to put it all together, I'm going to add 42 plus 75.6 plus 32.4, and that should total up to an even 150 centimeters squared. So today we found the surface area of rectangular prisms. It's like taking a cereal box and laying it out flat, and then finding the area of all of the sides of the box. And you find that by finding the area of all 6 rectangles and adding it together. Hopefully that wasn't super confusing. Do your best, ask questions if you have them, and have a super fun day doing math. Bye-bye.